This is EME 303. We are Group 21, and we're going to discuss how high a plane can fly. We're going to start with a discussion of our video we found on YouTube.
In the video, we can visually see that the airflow on the top of the wing is faster than the airflow on the bottom of the wing. But why is that? Essentially, the airflow on the top of the wing enters an area of lower pressure and speeds up as a result. In comparison, the airflow on the bottom of the wing enters an area of higher pressure and slows down. The reason for the change in speeds can be contributed to geometry. The wing is curved in the front and tilted up at an angle, but the air takes roughly the same amount of time on top as it does on the bottom to reach the tail of the plane. Therefore, the air on top must have a greater velocity in order to compensate for the longer distance, and as a result of the deflection of air downward, lift is generated, and this can be explained by the conservation of momentum, which is responsible for the differences in speed of the laminar flow.
Lift depends on the density of the air, the square of the velocity, the air's viscosity and compressibility, the surface area over which the air flows, the shape of the body, and the body's inclination to the flow. In general, the dependence on body shape, inclination, air viscosity, and compressibility is very complex. One way to deal with complex dependencies is to characterize the dependence by a single variable. For lift, this variable is called the lift coefficient, which is designated by CL. This allows us to collect all the effects, simple and complex, into a single equation. The lift equation states that the lift L is equal to the lift coefficient times the density times half of the velocity squared times the wing area.
The Bernoulli equation states that with an increase in velocity comes a decrease in pressure. Higher velocity of flow, lower the pressure. However, there are differences in pressure between the bottom and the top, because air flows differently over the top and the bottom. Over the top of the blade, a greater surface area would create a different type of pressure. The pressure loss over the top surface is greater than that over the bottom. This pressure difference creates a net positive force upward. However, with a high altitude and a decrease in density, this pressure force upward is negligible to the point where the pressure loss over the top of the blade and the bottom is no different.
In conclusion, airplanes fly due to manipulation of lift and Bernoulli's equation. The max height is affected by airplane speed and the density of the air. As your height increases, your density goes down. Also, as your height increases, there is less air above you, so the airplane must fly faster in order to balance out the forces. All of this affects how high a plane can fly.